In this segment I'm going to talk about division, and I'm going to be using repeated subtraction to show that. For those students that may not get the idea of their multiplication times tables, that they can do division with repeated subtraction, and hopefully showing that repeated subtraction is not the most efficient way, and that if they learn their times tables they can do that repeated subtraction or division a lot faster. But we're going to do division with repeated subtraction. So in the question 8 divided by 2, we typically say it's 8 divided into 2 pieces. What would their size be? Or we could say 8 divided into pieces of 2, how many pieces would there be? So if I'm using the subtraction method, then I might think of this question as I want to subtract 2 from 8 how many times? Or the other way I can think of it is I want to subtract something 2 times. What would that something have to be? What are the things that I'm going to subtract? So these are the two ways that we can think of our question using subtraction in our division. So if we're looking at the first way, I want to subtract 2 things from 8. Okay, so I take these 2 things, I do that once. I take these 2 things, I do it twice. I take these 2 things, I do it again. And I take these 2 things and I do it again. How many times was I able to subtract 2 things from the 8? 1, 2, 3, 4, so my answer is going to be 4. So that's to subtract 2 things from 8 how many times. The second way is talking about I want to subtract something, I don't know what it is, 2 times. So if I take this thing and I do it once and then I do it twice. If I'm going to subtract something 2 times, what are the things that I'm subtracting? Well, in each one of these I have 4. So 8 divided by 2 comes out to 4 again. So I'm subtracting something 2 times. In this case I'm going to have to subtract 4 little ones, and I'm going to do that once and I'm going to do it twice. So there's my 2 times. My answer to my question though is not how many times did I do that, it's what are the things inside. Trying to figure out how many times that's going to be, or what would those what size pieces that would have to be, again ties into the idea of a half. Subtracting something 2 times, how big would the pieces have to be? What number would I have to be subtracting? Would I subtract 2? Would it be 3? Would it be 4? Would it be 5? If it's going to be 2 times, it's probably going to have to be something that's half of 8. We can still have lots of discussion that's quite rich around what are we going to circle? What numbers would make sense to do it if I could only draw 2 circles? So in this question, 12 divided by 2, I want to subtract 2 things from the 12. How many times would I do that? So again, I can do it once, twice, 3, 4, 5, 6. So I can subtract 2 from 12 6 times, so I get my answer of 6. And again, if I want to subtract something 2 times, well, that's that half kind of concept again, so I cut it in half. That would be one of the things, and this would be my second thing that I'd have to do. What are the things? Well, inside each of these circles I have 1, 2, 3, 4, 5, 6. So again, my answer is 6. So that's using just my 12, breaking it down into single blocks. But we want to start talking a little bit about place value and using our base 10 blocks. So I'm going to do this question with some base 10 blocks as well. So I've rewritten my question 12 divided by 2. Here's my 12, but I've rewritten it with my base 10 blocks. And I've purposely said things, not ones, because now we're going to talk about, can we do this with whatever shapes we're talking about? We've already shown that we can take this 10 and convert it into a bunch of ones. If we take those, bring them up, and bring them up, I can take them and then I can cut them up like I just got finished showing. But can we do something with this 10 rod the way that it is? And I want to talk about that just for a second. So normally in our standard algorithm, we might say something like, does 2 go into 1? And the answer would be no, it doesn't. And so we want to talk to the students, where is that 0 coming from? What does it mean, 2 going into 1? Because you're not going 2 into 1, you're going 2 into 12. Where does that 1 come from? So if we want to think of it as, we can talk about it in subtraction, talking about the different shapes. The things that we're talking about are the shapes. So in this question, can I subtract 2 rods from what I've got here? And the answer is no, I can't subtract 2 rods. So this 0 means no, I can't subtract 2 rods. What I have to do then is trade them in for my 10 ones and do what we did before. Can I subtract groups of 2 away from 12, and yes, we're going to have a series of groups of 2, and we're going to have one group here, another group here, another group here, another group here, another group here, and another group here. So I'm going to get 6 groups, and so now I can do that. So that 0 stands for no, I can't take 2 rods. The things in this case would be rods. When I want to do it the other way, can I subtract something 2 times when it was in the rod format? Can I subtract something 2 times? And again, I can't subtract a rod 2 times, so I have to trade it in again. And now I could trade it in and I can cut it up into groups of 6. And I would have 1, 2, 3, 4, 5, 6. There's one group, and 1, 2, 3, 4, 5, 6. There's the other group. I can cut it into 2 groups, and each group would have 6 in it. And again, the 0 would stand in there saying, no, I can't take away the 2 rods. So in this question, 24 divided by 2, we could take the 24, cut them up into 24 singles, and cut out groups of 2. How many times would I do that? And it would be 12. Again, I could break this up into singles and say I can take them into 2 groups. I cut it in half, and each group would have 12 inside. I can do that. But that's very long and tedious. Is there a shorter way of doing it with this? Yes, there is. So going to our standard algorithm, 2 goes into 2 how many times? Well, I can say this question, I want to subtract 2 things from 24. Can I subtract 2 rods? And the answer is yes. How many times can I do that? Well, I can do that once. And so that's going to leave me with 4 left over. So 1 times 2, 2 rods is worth 20. So there's my 20. I subtract. I'm left with 4, and there's the 4 that I'm left over. Can I subtract 2 things from my 4? Yes, except now they're not rods, they're reds, and I can subtract it once, and I can subtract it twice. So can I subtract 2 things from my 4? Yes, I can do that twice, and so now I'm left with 0 left over. So there it is, using our rods and connecting it to our standard algorithm. In the second way, subtracting something 2 times, I take my picture and I just kind of separate it so it looks like this now. And my question is, can I subtract something 2 times? Yes, I can subtract something that looks like this. It's got a rod and 2 ones, and a rod and 2 ones. So it's the same thing, and I can do that twice. What are the things? I have 1 rod, which is a 10, and 2 ones, which is a 2. And I still get my answer of 12. Just a different way of looking at doing it. So now we have a slightly larger question, 156 divided by 12. And this is quite high as far as the kind of quality or size of numbers that we're going to be using. So a fairly high grade. But we're going to see it's going to work for these kinds of questions as well. So one of the options we could do is we could break this 100 flat into 100 little reds, and these into 50 little reds, so we have 156, and then we can take away groups of 12 and another group of 12 and another group of 12, and we'd find that we're going to do that 13 times. So to get the answer of 156. The other thing we can do is we could subtract something 2 times. Subtract something 12 times. What are those things? If I subtract something 12 times, I'd have 12 circles, and in each side of those circles I'd have 13 little red things in each one of those. But we want to find a shorter way of doing that, so we're going to talk about connecting it to our standard algorithm over here. So here we go. Can I subtract 12 flats from here? And the answer is no. So I can't subtract 12 flats from 1 flat, so I put my 0 up here. Then I'd have to take my flat and rename it or break it down into 10 of my rods. And so there's my 10 rods. So now I have a total of 15 rods. Can I subtract 12 rods from there? And the answer is yes. I can subtract 12 rods. Here's my 12 rods, 10 and 2, and I can do that once. So there's my 12 rods that I can take away. So I've taken my 12 rods away from my 15 rods, and it leaves me with 3 rods. There they are, and 6 ones. And I bring that down. There's my 36. Can I take 12 away from my rods now? No, I don't. So I have to regroup this into 31s. And now can I subtract 12 things from that? Well, there's 10 and 2, so I did that once. 10 and 2, that's twice. 10 and 2, that's 3 times. I subtracted 12 3 times for my 36, and that leaves me, I took up 36, I don't have any left over, and I get my answer of 13. So we've talked about changing this to 156, then taking out groups of 12 or something 12 times. We've talked about how to do it with the base 10 blocks for subtracting 12 things from 156. And this final one's going to show us how to subtract something 12 times. What would those somethings be? So the first part is, can I subtract 12 anythings from one whole flat? And the answer is no, I can't. I have to break it up somehow. So I'm going to do the same thing I did before. I'm going to break it up into 10 rods. So I've put my 0 here because I can't break up my 12, my blue flat there. So can I subtract something 12 times from this group? This is a bit of a problem over here, so let's just worry about the rods for now. If I subtract one rod once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I can subtract something 12 times. I can subtract one rod, and one rod is a 10, so I'm going to say 1 in the rods column or in the tens column. So that's now used up 120 altogether, and I subtract that, and it leaves me with 3 rods left over plus 6 ones, so there's my 3 rods and my 6 ones. So now I've taken my rods and I've subtracted something 12 times. I've subtracted one rod 12 times. Can I subtract anything else 12 times? Well, not the way it is right now. I don't have enough rods and I don't have enough ones. So again, I'm going to transfer these over and change them into groups of 10 reds. So I've traded them in for 30 reds. So now I have a total of 36, just like I have here on my standard algorithm. And now I want to find out, can I subtract something 12 times? Well, if I subtracted 1, it's going to take me 36 times. If I subtract a group of 2, that's going to be 18 times. If I subtract a group of 3, that'll come out to be 12 times. So there's 1 group, 2 groups, 3 groups, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's my 12 groups, and how much was in each group? What are these things? Well, they're groups of 3. So I did 12 groups of 3. 3 times 12 is 36, and I subtract and I get 0. So again, I get my answer of 13. So we're still getting the idea of having to regroup, and we still have our place value, except we're using subtraction instead of multiplication, and it still ends up working the same way. But having students see that if they understand their multiplication facts, it's going to go much faster instead of guess and check as to what numbers we have to use all the time. And hopefully they'll see that the multiplication and knowing their multiplication facts is a much more efficient technique for doing division. And but subtraction does allow them to work, and you can still use your place values and your ideal around subtractions to do a shorter version instead of changing my 156 into 156 little blocks. We can still use our place values, and it still uses our standard algorithm, except we're thinking of subtraction instead of multiplication to do it. Just another way.